Well, welcome back to our, fourth chapter? This is our fourth series of lectures on relational databases. And in this one, we're going to be introduced to the basic SQL, Standard Query Language, or SQL as it's been known for a long time. Standard Query Language is the standard language for relational databases. Because of this standard, converting to another relational database management product is not expected to be too expensive or time-consuming because most systems follow the same language standards. There are versions of SQL that have been created to add features with different brands of databases. However, almost all can execute SQL in its standard form. In this series of videos, we're going to study SQL data definitions and data types, specifying constraints in SQL, basic retrieval queries in SQL, insert, delete, and update statements in SQL. We're just going to be learning a whole bunch of good stuff, along with some additional features of SQL. The SQL language is considered one of the major reasons for the commercial success of relational databases. SQL stands for Structured Query Language. Originally, it was called SQL, Structured English Query Language, and was designed and implemented at IBM Research as an interface for an experimental relational database system called System R. SQL is now the standard language for commercial relational database management systems. A joint effort by the American National Standards Institute, ANSI, and the International Standards Organization, ISO, has led to a standard version of SQL, ANSI 1986, called SQL 86 or SQL1. SQL is a comprehensive database management language. It has statements for data definitions, queries, and updates. Therefore, it is both a data definition language and a data manipulation language. You recall we discussed the various languages needed for a relational database in a previous series of lectures. In addition, it has facilities for defining views on the database, for specifying security and authorization, for defining integrity constraints, and for specifying transaction controls. SQL uses the terms table for relation, row for tuple, and column for attribute, respectively. You recall in the relational database terminology and in a series of lectures, I did mention that you're going to be hearing different terms representing the same thing before we were through with this series of lectures on relational databases. And here you have it. SQL uses table for relation, row for tuple, and column for attribute, respectively. Because of my background, I'll be using these terms interchangeably. Early versions of SQL did not include the concept of a relational database schema. All tables were considered part of the same schema. The concept of an SQL schema was incorporated starting with SQL2 in order to group together tables and other constructs that belong to the same database application. An SQL schema is identified by the schema name and includes an authorization identifier as well as the descriptors for each element in the schema. Now, in our classroom projects, we're going to be using an open source database called MySQL. And MySQL doesn't really use the term schema. So in any instance where I'm mentioning the term schema in the confines of this lecture, you might consider changing that to database because that is the term MySQL uses for a relational database schema. They call it the relational database. The main SQL command for our data definitions is the create statement. An SQL schema is identified by a schema name and includes an authorization identifier to identify the user or account who owns the schema, as well as descriptors for each element in the schema. Schema elements include tables, constraints, views, domains, and other constructs, such as those authorization grants that describe the schema. All SQL statements end with a semicolon. A schema is created via the create schema statement, which can include all the schema's element definitions. Alternatively, though, the schema can be assigned a name and an authorization identifier, and the elements can be defined later. This example creates a schema called company with authorization identifier J. Smith. Note that each statement in SQL ends with a semicolon. Since we will be working in MySQL, I should let you know that this command doesn't work in MySQL. In MySQL, the command is create database company, and a separate grant command is used to define privileges. Let's try it. So I scroll back across my Windows 8 home screen until I find the tile. There it is, that says MySQL. I'll select that, and it's prompted me for my password, so I'll input my password, and it brings up the MySQL command line. Let's input our first MySQL command, show databases. Now, as we've already discussed, in standard relational database terminology, the word would be schema. So it would be show schemas. However, MySQL uses the word database instead of schema, so we say show databases, and we end with a semicolon, and that shows us a list of the databases that exist on this server. So we will use another SQL command, drop database company, end it with a semicolon. A word of caution here, when you're using the word drop in front of anything in SQL, make sure that you're the person that has the authority to do that. So we're going to drop database company. It says it did something, so let's do that show databases again. Semicolon. And I see now that the company database is gone. Let's do another SQL command, except we're going to substitute database for the word schema. Create database company, and put a semicolon in there, and it says it did something, so let's show databases with our semicolon at the end, and bingo, we have a company database that we have just created. So there you go, we have input our first 3 MySQL commands. We did a show databases, then drop database, and now we've input a create database. So that is the beginning of many that we're going to be doing before the semester is over. This has been a fairly long video lecture, so I think we ought to take a break at this point. And we haven't talked about our mystery word, have we? Let's make our mystery word, since we've been talking about MySQL so much, let's make our mystery word MySQL. When you finish that, go out to our coursework section and check your knowledge on the material that we just discussed. And when you're ready, come on back for the second in our series on basic SQL.